Hi, welcome my dear students. Right. Uh, Today we are going to discuss certain problems. Yesterday we have discussed certain results in similar triangles. Now we have the third result based on that, and we are going to discuss certain problems based on them. Right. You see, my dear students, what we have here is if two triangles are similar, this result very important. Then the ratio of their areas is equal to the squares of their corresponding sides. Number 2, medians. Number 3, altitudes. Number 4, angle bisectors. Right? If two triangles are similar, then the ratio of their areas is equal to the squares of their corresponding sides, medians, altitudes, and angle bisectors. Already, my dear students, how we are going to prove this result? We know that if two triangles are similar, if two triangles are similar, then we already first result what we have studies is area of their ratio of their areas, right? Ratio of their areas. You see, my dear students, what we studied first result, ratio of their areas, right? Ratio of their areas is equal to, okay, squares of their corresponding sides, squares of their corresponding ratio of, right, ratio of squares of their corresponding sides, right? This is what the first result we have studied. Next, if two triangles are similar, right, then ratio of their sides, right, ratio of their sides is equal to ratio of their corresponding, right, corresponding, number 1, medians, number 2, altitudes, right, altitudes, number 3, angle bisectors, like this, angle bisectors, this, right? By combining these two, right, by combining these two results, my dear students, now if two triangles are similar, then the ratio of their areas, okay, then the ratio of their areas, if we take like this the diagram, right, wonderful, if you take like this ABC or DEF or something, ratio of their areas, that means area of triangle ABC divided by area of triangle DEF, right? By combining these two results, my dear students, what we can say, right, what we can say is, right, first of all, ratio of their areas is equal to squares of their corresponding sides. That means, you see, AB by DE whole square, what we can say, that is equal to BC by, right, EF whole square. We can say BC by EF whole square, that is equal to AC by DF whole square. This we can say. And also we know that ratio of their corresponding sides is equal to ratio of their corresponding median. This is equal to ratio of their, okay, now if we take the median as something like this, suppose X and Y here, these are the medians, like AX by AY, okay, AX by DY, they are medians, means now you are going to get AX by DY whole square, because by the second result, ratio of their sides is equal to ratio of their corresponding medians, right, my dear students? Suppose if for next one we have altitude, suppose if I draw perpendicular like this, let us call it as X dash. Now let us call this as Y dash. This is what the perpendicular altitude. Then that is equal to AX dash by DY dash whole square, like this. Next we have angle bisector. Let us write, this is what the angle bisector. Here also angle bisector, what we are having, let us call it as X double dash and we call it as Y double dash. This is equal to now AX double dash by dy double dash whole square, where you see, my dear students, here you know that what, right, fine, area of triangle ABC by area of triangle DEF. Now this is equal to, by combining these two results like this, by combining these two results, we have got that ratio of their areas is equal to squares of their corresponding sides, that is equal to squares of their corresponding medians and altitudes and angle bisectors. By this way, we have got this wonderful result, my dear student. Therefore, this third result, if two triangles are similar, then the ratio of their areas is equal to the squares of their corresponding sides, medians and altitudes and angle bisectors. In this beautiful way, by clubbing the first 1 and 2 results, we will be getting these. Right? Now let us do certain problems. Now see this particular problem, my dear students, is lengthy but it is very simple. Whenever a problem is having more number of steps means it is very simple problem basically. Don't think that it is a complicated problem. Okay, my dear students, you see now equilateral triangles are drawn on the 3 sides of a right angle triangle. Show that the area of the triangle on the hypotenuse is equal to the sum of the areas of triangles on the other 2 sides. This is what actually we require to prove. That means, you see, my dear students, we are having a right angle triangle like this. We are having a right angle triangle like this, A, B, C. This is a right angle triangle. We are having equilateral triangles are drawn on the 3 sides of a right angle triangle. Now I am drawing one equilateral triangle like this, right? Let us call this as some D. This is equilateral triangle like this. Now we have E like this. This is also equilateral triangle. This is another equilateral triangle we have got like this. So that the area of the triangle on the hypotenuse, the area of this equilateral triangle which is described on the hypotenuse is equal to, we need to prove sum of the areas of the triangles on the other 2 sides, right? This is what actually we require to prove. Okay, now you see, my dear students, how we are going to do this particular part is, right, we have here ABC is a right angle triangle like this, right? We know that actually it is a right angle triangle means AC square is equal to AB square plus BC square like this. AC square is equal to AB square plus BC square. This thing we know that, of course. Now we need to prove that area of the triangle on the hypotenuse. Now, okay, area of triangle, right? Area of triangle ADC, this is equal to, okay, the formula for equilateral triangle is root 3 by 4 A square. Here the side AC, AD, DC all are same like this. These all are same because it is a equilateral triangle, root 3 by 4 into AC whole square. This is what area of triangle ADC. Next you have here area of triangle AEB like this, AEB. This is equal to root 3 by 4 into, right, AB whole square like this. Root 3 by 4 into AB square next. Next you have here area of triangle. Okay, this let us call it as some F like this. Area of triangle BFC like this. This is equal to root 3 by 4 into BC whole square like this, right? Now you see, my dear students, we know that actually in equilateral triangle hypotenuse square equal to sum of the squares of the other 2 sides. Therefore, you see, we can easily say that actually root 3 by 4 AC whole square, we just multiply, right? Okay, you just, what I am telling is we have this, you just multiply root 3 by 4 on both sides to this. Then what you will get? Root 3 by 4 into AC square. This is equal to root 3 by 4 into AB square plus BC square you are going to get, right? That means this is actually area, okay, we just multiplied both sides. This is what actually area of triangle ADC, which is the triangle described on the hypotenuse. This is equal to area of triangle AEB. You are having here AEB plus area of triangle BFC like this. Wonderfully we have got, my dear students, this proof, you see. Okay, therefore area of triangle ADC, because this is nothing but this, and just we multiplied root 3 by 4 on both sides to this. Then you have area of triangle AEB plus area of triangle BFC. Therefore area of the triangle which is described on the hypotenuse of the right angle triangle is equal to sum of the areas of the triangles which are described on the both the legs. In such a beautiful way we will be getting this particular problem, right? See the next problem, this is the third problem in your textbook, and this is the second problem in our thing. Okay, DEF are midpoints of sides BC, CA and AB of triangle ABC. Find the ratio of areas of triangle DEF and triangle ABC. It's a very simple and basic problem, my dear students. We have here this triangle ABC like this. We have here triangle ABC. In this triangle ABC, DEF are the midpoints. D is midpoint of BC, right? Right, like this. And E is midpoint of CA, like this. E is midpoint of CA, like this. And F is midpoint of AB. Okay. Find the ratio of the areas of triangle DEF and triangle ABC, like this. This is what we require to find actually, right? Find the ratio of the areas of triangle DEF and triangle ABC, like this. See how we are going to do this thing. The solution part. We know, my dear students, that right, area of actually, right, now they are asking ratio of areas of triangle DEF and ABC. You know that actually area of triangle DEF, in plane geometry, right, you know the areas. Actually, see, my dear student, I want to tell you one thing here. Here, whenever, see, these are the two midpoints. By midpoint theorem, line joining of two midpoints is parallel to the third side and half of it. Therefore, this is parallel to this you are having here. Similarly, this line joining of two midpoints is parallel to the third side and half of it. Therefore, this is parallel to this and half of it. Now, this is also parallel to the third side and half of it. That means, you see, my dear student, this is parallel to this. This is parallel to this. That means this is a parallelogram. Now, in a parallelogram, the diagonal will divide this parallelogram into two equal areas. That means this is x, means this is also x, right? And similarly, my dear student, this is also a parallelogram. This is parallel and these are parallel. And this diagonal will divide this into two triangles of equal area. That means if this is x, means this is x. Similarly, this is also a parallelogram like this, because the diagonal will divide that into two triangles of equal area. Therefore, if this is x, means this is also x. Therefore, four equal areas. We can say that now area of triangle DEF is equal to 1/4 of area of triangle ABC, like this, right? Now you need what actually? Area of triangle DEF by area of triangle ABC, right? You bring that side, like 1/4. We have got what? 1/4. In such a simple way we got this problem, right, my dear students? And how we got also I explained. These are divided into four equal areas, x, 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 and this is 1x, means this total is 4x. That's why 1/4. Such a beautiful and elegant way we are getting this particular result, right, my dear students? In this way we will be doing this particular problem. Now see this particular problem, very very important, and it is a star marked problem, my dear students, right? Like this, star marked problem. In triangle ABC, XY is parallel to AC, right? We are having here in triangle ABC, this is what triangle ABC we are having here. In triangle ABC, XY is parallel to AC, like this. XY is parallel to, okay, they given that what? AC in your problem, okay. Okay, no problem. XY is parallel to AC, not this is actually BC, right? XY is parallel to BC, and XY divides the triangle into two parts of equal area. Find AX by XB ratio. See, they given that XY parallel to BC and XY divides the triangle into two parts of equal area. This is x, means this is x, two parts. Find the ratio of now AX by XB. This is what actually we require to find. Once you see, my dear students, once this is parallel to this, this corresponding angles are equal. This angle equal to this angle, and this angle is also equal to this angle. That means, you see, my dear students, in this part, what we are going to get, okay, once by AA similarity, and this is the common angle. This is the common angle. By AA similarity, we can say that triangle AXY is similar to, right, triangle ABC, like this. Triangle AXY is similar to triangle ABC. Therefore, you know, my dear students, area of triangle AXY divided by area of triangle ABC, this is equal to area of triangle AXY. Once both triangles are similar, then we know that it is equal to squares of their corresponding sides. That means AX by AB whole square, like this, right? AX by AB whole square. Wonderful. Now they given that actually area of triangle AXY is x by and this total area is x plus x, that is now 2x. Now x and x will cancel, that is 1 by 2. Now you have got ax by ab is equal to 1 by root 2, because ax by ab whole square equal to 1 by 2 means ax by ab equal to 1 by root 2. But we need what? Ax by xb, but we have got here ax by ab. Now let us take reciprocal. If you take reciprocal, ab by ax, that is equal to root 2 by 1, like this. Now subtract 1 on both sides, then what you are going to get? If you subtract 1 on both sides to this, what we are going to get? ab minus ax by ax is equal to root 2 minus 1 by 1, like this. Because what we are doing is just subtracting. That means here I am writing here ab by ax minus 1 is equal to root 2 by 1 minus 1. Just then if you take LCM, this become ab minus ax by ax, that equal to root 2 minus 1 by 1, like this. Now ab minus ax, that is nothing but xb. xb by ax is equal to, right? You got it as root 2 minus 1 by 1. Now we need actually ax by xb. You just take the reciprocal for this. Ax by xb, nana, this is equal to what you will be getting? 1 by root 2 minus 1. This you can multiply and divide. You can rationalize this. Multiply and divide by root 2 plus 1, like this. Now this become root 2 plus 1 by root 2 whole square minus 1 square. 2 minus 1, that is 1. Therefore ax by xb is equal to root 2 plus 1. In this beautiful way, we will get this particular problem, right, my dear students? Please observe, it's a very nice problem, right? See this particular very simple problem, my dear students, the fourth one in our thing. Triangle ABC is similar to triangle DEF. BC equal to 3 cm, EF equal to 4 cm, and area of triangle ABC is 54 square centimeter. Determine the area of triangle DEF. Very simple problem, my dear students. You know that, right? Simply let us take this is ABC. Like this is ABC. In this you have here, right, ABC, and ABC is similar to triangle DEF. You are having something like this, right? Fine, my dear students. Some DEF. This is just a rough diagram we are having here. Okay, Nana, we know that the area of triangle, once they are similar, that area of triangle ABC by area of triangle DEF, this is equal to squares of their corresponding sides. Squares of their corresponding sides, that means BC by EF whole square. This is BC by EF whole square. This is equal to AB by DE whole square, and this is equal to AC by DF whole square. AC by DF whole square, like this, right? And you see, my dear students, in this area of triangle ABC, they given it as 54 by, we want area of triangle DEF. Right, my dear students, we want what? Area of triangle DEF, right? This is equal to, now they given that BC by EF whole square, that BC is now 3 by 4 whole square, like this, right? Now this is equal to 9 by 16, right? Now see, my dear students, we can easily cancel also, right? Fine, 6 9 ones are 9 6s. Okay, 9 5s 45, 9 6s 54, like this. Wonderfully we can do. Now from this what we have got? Area of triangle DEF. Area of triangle DEF is equal to 16 into 6. Right? Just cross multiply. 9 by 16, that is 9 ones are 9 6s. 16 into 6. Therefore, area of triangle DEF is equal to 16 into 6. 16 5s 80. It is 96. Right? That means this is a bigger triangle actually. This is a bigger triangle. But we say rough diagram as I mentioned you. Then we have what? Area of triangle DEF equal to 96. Very simple and elegant problem, my dear students. You can easily observe this particular problem. See how beautifully we have got this problem, right? Okay, now see my dear students, this fifth problem of today's class. ABC is a triangle and PQ is a straight line meeting AB in P and AC in Q. If AP equal to 1 centimeter and BP equal to 3 centimeters, right? AQ equal to 1.5, CQ equal to 4.5. Prove that area of triangle APQ is equal to 1 by 16th of area of triangle ABC, right? It's a wonderful problem, my dear students. Let us draw the diagram of this. How we are going to draw, my dear students? You see, this is now ABC like this, right? They given that PQ is a straight line meeting AB in P. AB in P, somewhere else here like this, P, and AC in Q. AC is in Q like this, right? PQ is a straight line. AP equal to 1 centimeter and BP equal to 3, 1 by 3 ratio, 1 by 3, very good. AQ equal to 1.5 and CQ equal to 4.5, wonderful. This is also 1:3 ratio. That means the ratios are same. Okay, my dear students, very nicely here. Okay, what we can say that in this triangle AP by PB is equal to AQ by QC, we have got, that is nothing but 1 by 3, because that is 1.4 by 4.5, that is equal to 1 by 3. By the converse of basic proportionality theorem, in a triangle, if your line is dividing two sides in the same ratio, then it will be parallel to the third side. That means we have got, my dear students, here now PQ is parallel to BC. Once this is parallel, you know that corresponding angles are equal. This angle equal to this angle equal to this angle. PQ is parallel to BC. We have here like this, right? Once this is parallel, my dear students, you know that by now this is the common angle for both the triangles. What we can say is that triangle APQ is similar to triangle ABC like this. Triangle APQ is similar to triangle ABC, right? Once triangle APQ is similar to triangle ABC, my dear students, we know that area, once they are similar, area of triangle APQ divided by area of triangle ABC like this. This is equal to squares of their corresponding sides, right? Squares of their, that is nothing but AP by AB whole square like this. Now AP is 1, now AB is 1 plus 3, that is 4. 1 by 4 whole square, that is now 1 by 16, right? Therefore, you see, my dear students, we have got area of triangle APQ. Area of triangle APQ is equal to 1 by 16th of area of triangle ABC. Such a beautiful way we are getting this particular result, my dear students. Please observe, right? Wonderful. Okay, this is what the 7th problem in your textbook, IPE book. See, now we have the other problem. The areas of two similar triangles are 81 square centimeter and 49 square centimeter respectively. If the altitude of the bigger triangle is 4.5 centimeter, find the corresponding altitude of smaller triangle. Right, my dear students, we did already these results. You see, my dear students, we are having here ABC. This is what one triangle, right? And we have another triangle like this, DEF. DEF is another triangle, right? If you take, right, like this, X, Y, like this, right? Fine, they are the altitudes, right? They are the altitudes. We know already in the beginning we discussed one result, my dear students. Okay, what are that? Here they given the triangle ABC similar to triangle DEF. If two triangles are similar, ratio of their areas is equal to squares of their corresponding sides, squares of their corresponding medians, squares of their corresponding altitudes, squares of their corresponding angle bisectors also. Therefore, what we do is area of triangle ABC divided by area of triangle DEF like this. DEF. This is equal to squares of their corresponding altitudes, AX by DY whole square. We will be getting it like this. Now they are there, the areas of two similar triangles, they given it as already, right, my dear students, 81 by 49. That is equal to, And the altitude of bigger triangle is they given it as what? Altitude of the bigger triangle they given it as 4.5 centimeter. This is now 4.5 whole square by dy, right? Like this, 4.5 by dy whole square. And you see, my dear students, very simple way we can do now. 4.5 by dy, if we take this equal to square root of 81 by 49, like this. This is equal to 9 by 7, like this. Right? Now dy, okay, fine. Now we want, however, now 4.5 ones, 4.5 twos we have here, like this. Now dy is equal to 7 by 2. From this, dy is equal to 3.5 centimeter, like this. dy is equal to 3.5 centimeter. In such a beautiful way we have got this particular problem. My dear students, you please observe. Right? Very nice. Okay, thank you for watching. Thank you very much.